Okay, good morning, everyone, or good afternoon, good evening. This is Cherry Kubota. I'm a professor at The Ohio State University. Welcome to Indoor Ag Science Café October. So today is a special program, so I'm so excited having 3 company representatives to talk about their technologies. But just before starting, again, this is a funded project by USDA, and then there are multiple PIs and universities participating in this. Idea is to communicate about the science and technologies that are supporting indoor agriculture or vertical farms. All right, so the little bit of future schedule. So the November, we have another talk about strawberries and tomatoes growing under electrical lighting or a vertical farm setting. Shoko Hikosaka is going to talk. And then December, we will have Dr. Roberto Lopez talking about the basics of crop response to temperatures. So, and then more coming next year. So please look forward to that. As usual, we do this Tuesdays, 11 a.m. Eastern time, unless there is a conflict or the time zone issue. So anyway, so glad to have 3 companies today. The first presentation is RAYN Growing Systems. Michael Lichter is going to talk their technologies, and CELINE, CELINE, Simon Meijer is going to talk about their technology. Welcome, Simon. And then the last one is Certhon. Jaap Weerheim is going to talk about their interesting technology. So I'm just finishing up, and then I will let Michael is taking over. I stop share and have Michael.
Good. Okay. So RAYN Growing Systems, we were founded a couple of years ago, and we now created a RAYN vision system, basically a camera system and analytic system to aid initially scientists in their research work and creating images and results for their research. So today it's my colleague, Dr. Alexander Kuchera, and myself. We are presenting the system here, and we'll jump right in here. All right. So a quick word about multispectral images and multispectral concepts. A lot of you already know and understand that, so I'll be quick here. So usually when we take images of something, we take images so the human eye can see things. And we take those images usually in 3 spectral bands, usually red, green, and blue, which are tuned to be okay for the human eye. And that works okay for us. But there is a lot more. If we're looking at hyper or multispectral cameras, we can look at taking images at a much more wavebands that are not necessarily visible to the human eye. So we can just create multiple images and stack them on top of each other. So rather than red, green, and blue, we can take an awful lot more. And based on those images, we can create a signature, a pixel signature for every single pixel, spectral signature, and see additional information generated out of those images that the human eye cannot see, but a computer and other things can actually analyze that. So if we have, for example, a normal image of a normal plant, RGB images looks nice, looks okay. But if we take that same image on the multispectral camera system, suddenly there's potentially a lot more that can be seen in that image way before a human eye can see that. So we can detect problems, issues, a couple of other parameters way before a human eye or a person could see what's going on. So there's a couple of differences between taking images with a normal camera. If we have just a normal camera, we can take images and analyze general monitoring. We can just look at the plant and see how it looks like. We can look at leaf area and leaf area over time. We can look at grow rates. And there's more we can do, but that usually already requires a lot more post-processing, artificial intelligence, and a couple of other things to be useful. With multispectral images, suddenly there's a lot more information that can be fairly easily analyzed. Plant phenotyping, pathogen and diseases, water stress, pigment level, chlorophyll, carotenoids, anthocyanins, photosystem efficiency, nutrient transport efficiency, just for a couple of examples, are all a lot better visible by using multispectral cameras. The trouble is, well, multispectral cameras, they aren't cheap. They're usually quite expensive, and they're a highly precise measurement technology, and you pay for it usually. So that is a problem because you can't deploy those cameras on a large scale. It's cost prohibitive. And usually a lot of people then take plants to those cameras because they only have one and analyze it there, which is involved in a lot of labor, or a robot is used to take the plants to the camera. So it's a problem, basically. Those things are not cheap, but they're highly precise, very high-level instrumentation cameras. So we looked at what can we do here? Do we actually need that high precision and that very fine accuracy? So we looked at it. Alexander Kuchera, our plant scientist, looked at what kind of indices can we calculate and what kind of wavebands, what kind of spectral lines do we actually need for them? Do we need that very high precision, that very fine resolution? And it turns out we don't for the standard indices we want to calculate. So what we did, we do it differently. So instead of taking a full color image and apply various filters to get to the nanometer resolution for each image, we actually take a monochrome image and light up the plant with different color LEDs. And then we turn on one LED color at a time and take one image with a spectrum at a time. And from there, we assemble those monochrome images and assemble a multispectral image cube and generate multispectral image cubes that are good enough for most of what we are trying to do here at a fraction of the cost. And that's a system that was patented by RAYN Growing Systems. So we do it differently. There's a couple of positives and negatives about this. The positives are it comes at a fraction of the cost. The problems is, in order to take an image, you need to take the image in the dark so that the camera can light up the surface and is not interfered with normal general lighting coming from the normal plant lighting. But we included some communication methodologies from the camera to communicate to the lighting system to turn off the lights when it wants to take an image. That ranges from MQTT network integration all the way to digital inputs and outputs that is just shorting out the 0 to 10 volt line and turns off the lights that way. So very simple to pretty complex. There's ways of doing it, but also if you just need to take one image during the day or one image per day, you can just take an image at night and everything is fine. It's not a problem. All right, so this is the big difference how we do it. We light up the surface with different colors, take monochromatic images and assemble those images into a multispectral image cube. Big difference. So our camera is a small little unit that can be deployed near or above the grow bed, grow area. It has a built-in scheduler, so it has a real-time clock. It knows when to take an image. You can set it up and leave it at the experiment for a couple of weeks or a couple of months. It will take its images whenever it's programmed to take the images. You can use it in a standalone operation, just set it up in the grow area and leave it there and retrieve the images once the experiment is done. You can also have it online, Wi-Fi communication to the analytics software and analyze live images. It stores the images on board. There's an SD card on there, and depending how big the SD card is, you can store an awful lot of images there. Wi-Fi communication to the PC or building infrastructure. It has the built-in light engine. It has 1280 by 800 pixels, and it can be supplied with 12 to 24 volts, 4-inch diameter, 100 millimeters. It can be flange mount or quarter-inch UNC mount for the normal camera hardware that can be bought in the standard camera shops. On board, it has a built-in web server where you can configure the whole thing. And you can take sample images to make sure that it's positioned correctly, but you can also configure light triggers, calibration, image cube generation, how it's communicating to the analytics software, also how it's communicating to a light system, either digital in or out, or via protocols like MQTT. And you can set up which kind of image cube you want to generate, what kind of lights, wavebands you want to use. And it integrates seamlessly, for example, with our RAYN Circadia software we have here on the right, that it integrates there and communicates, hey, I want to take an image, and Circadia will turn off the lights during image taking, and after that, it will turn the lights back on again, and everything is fine again. So there's various methodologies that we can use. So all of that is built in the web server on the camera itself and can be configured from there. The camera is a closed source system that we are building and we are selling. So we can have the camera above the plants. It will take monochromatic images, and it's doing the processing on board and turns that into a multispectral image cube. From there, it can be downloaded and it can be analyzed either with our own analytics software, or you can just store it on a file storage system and park it there, and then analyze the whole system from there and analyze it over and over with different analytics parameters, different settings, different ways of analyzing, or different workflows. That is also possible. Or with the file storage, you can also use those files to be analyzed by other third-party software. So we can analyze things like leaf area over time, is the grow rate, how quickly do things grow, antocyanin content, for example, and many, many more. The interesting thing is the RAYN Analytics software is an open source project. So scientists can actually use that and extend the functionality to cater for their own parameters, for their own indices they need to analyze. We're using an engine underneath, under the hood. It's called PlantCV, which is extremely well documented and very popular in the science community. But we put a wrapper around that so that is easy to use and also easy to extend with your own workflows or own needs that you need for your experiment, for your dissertation, for your documentation. One of the very first analytics we've done here, for example, is the leaf area and grow rate over time. And we already see this was not very well separated from the rest of the lab. So we get a couple of dimples, but this was the very first experiment we ran here. And you can see on the right that the grow rate is plotted against time, and it's slowly growing for those 14 plants that we see here. There's also third-party analytics software packages that we can use. For example, one is Envy, which is a commercial tool which is doing visualization and analysis. It comes from the satellite imaging community, but it's doing also a lot of parameters that are really useful for plants specifically. Close-up Gerbil is an open source tool that can also be used. Multispec, another open source tool on a different license. And also PlantCV, which we are also using under the hood. And you can program a lot of things using PlantCV to analyze multispectral image cubes. So our image cubes are compatible with all of those software packages as well. A couple of applications that we are doing is, or that can be done, is one of the problems is having actionable items out of the data coming out of the analytics or the software in the system. So it's nice that we analyze things and that we get data, but now what? What happens with all of this? So we can also process these images live and generate the data in a live fashion. We can publish those live parameters, for example, over MQTT, and that information can be picked up by other systems on the network, in the greenhouse, and the results can be acted upon by other systems. So, for example, If the system detects water stress, it can ping the fertigation system, hey, this corner of the greenhouse needs a little bit more water. Those plants are screaming for water. Diseases, integrated pest management integration. We can talk to that system, if that understands MQTT, and do actions directly based on what the analytics learned. One of the things that we've been experimenting around with our system, we're taking a multispectral image. It's getting processed live, for example, analytics. We're taking out the anthocyanin content, and we got a requirement the anthocyanin content needs to be between X and Y. And if it's too low or too high, we can adjust the spectrum of the lights using multispectral lights and manipulate the plants or induce very specific light into the plants so that the anthocyanin content either gets more or less, and regulate the output and ultimately generate repeatable aesthetics quality results based on those kinds of image and the closed loop regulation system we have here. So that's another actionable item. We are taking the image, we generate data out of it and react upon it, and we are ultimately improving quality or other things based on that kind of data. All right, so we have multispectral image creation for reasonable cost. That's our camera that we're selling. We have an analytics package. We are integrating, or you can integrate your own analysis workflows into a simple UI. There's an API which is really simple to use. It's an open source project. It's community and extension. And based on the data that the system is spewing out, people can also create closed loop regulation systems for actionable results and getting better quality of the crops they're trying to grow. That's kind of what we're doing in our 15 minutes. If you need any more information, let us know. Basically, website is right there. Get in contact with us. Thank you.
Great. Thank you, Michael. It's quite interesting. So everyone, you can use your microphone or you can type in the chat your questions. And Michael or other colleagues of Michael might be able to just, answer in the chat also. But we do have a few more minutes to answer your quick question. While you are thinking about, oh, here's a question. Is Image Cube available now?
The RAYN vision system, it's not quite available yet. We're still developing. It should be available early next year.
Excellent.
That's what we're shooting for.
So we got a very, very fast. Yeah, thank you. So I'm interested in using this for, are you familiar with terminology? We use graphical tracking. So there's a ideal growth curve of the plants. And then following that is really good because you have a near-term projected yield coming up in a vertical farm. And then not exceeding that, not going under, but right on track. And then I was thinking this might be a really good, particularly after canopy close. It's very difficult to do the graphical tracking just by canopy size. I mean the leaf size. Yeah. So I was wondering if this can be used for that type of application.
Certainly in the early stages when the leaves are not overlapping like we've seen here in one of the examples. Once it's overlapping, Alex, what are your thoughts on that? It's getting a little bit more tricky at that point.
It is getting more tricky, but we're doing our first tests on similar setups. So I can't give you a sure answer for now, but we are working on this.
Yeah. Or at least a younger stage. Because
that's possible.
Canopy closure is usually, I don't know, 1 week before. I don't know how soon. Jan might be able to. Yeah, but anyway.
Initially we can probably, or the grower can put a curve, a band. It needs to be within this band. If it's below, we need to do something. If it's above, something else needs to happen. And the actionable item depends on, is it more fertigation? Is it more or less light? Is it more CO2? Those things can be looked at, what needs to be done in order to get the grow rate back to where it needs to be.
That's right.
There's another question in the chat I see here. So the area and lens distortion. Yes, we do have lens distortion like we have on every camera, and we are having a system that calculates or basically we have a lens distortion system that takes care of that. So that the pixels that are far out actually come back at the same size as the pixels in the middle. So we look at our lens, we look at the distance, and we have a checkbox that allows to do this distortion of the lens. Yes.
Okay, and then I think Saeed, I see your hand up.
Thank you, Michael, for the very interesting topic. I love what you are doing. So can you elaborate a little bit more about the last slide that you mentioned? You can manipulate the plant spectrum requirement by using your camera. Is that possible for all plants, or you have done for the few plants? What's your final result, and what's your envision for the future?
There's a lot of research going on right now with multispectral lighting and tuning of certain crop parameters based on various wavebands that are shining onto the plants, and anthocyanin is one of them. But there's a lot of other parameters that can be directly influenced by putting very specific wavebands onto the leaves and onto the plants. And it's still a relatively new field because those LEDs are now becoming more and more available. Those multispectral lights are more available, and they're getting more into the universities. There's a lot of research going on. We've done experiments on leafy greens and with anthocyanin, and we're looking at those topics as we speak. Basically, how can we manipulate anthocyanin content? But there's a lot of scientific papers out there about that specific light wave bands can manipulate very specific crop parameters.
Right, great, such as blue light and UV light. Yeah, okay, so I like to cut here because it's running out of time. Michael, there's a question, one more question, so maybe you can answer in the chat. And then next speaker is Simon. Simon is gonna talk about online nutrient analyzer.
Thank you, Cherry, for your invitation here. I gladly share my screen with you to tell something about nutrition measurements. Nutrition measurements with CELINE horticulture, as we named it. I will get back on the name, where it's coming from. I will explain shortly what CELINE actually is, why it's interesting to follow nutrition measurements more closely in the greenhouse. How does it work? I will tell something about the technology behind it, and how you can implement it and how you can use it. So first of all, what is CELINE? As a company, we did launch a measurement technology that is known within the laboratories, but not in the greenhouse. We made it a plug and play laboratory, actually fitting in the greenhouse on the spot, doing all the measurements of irrigation water, drain water, automatically. So it takes samples from the either batches that are made ready, either in the system, in the piping. It's self-calibrating and self-cleaning, and that makes it far more interesting than all kind of handheld products that only measure one nutrition element, for instance. And it's real time. It delivers the data really quickly. Okay, this is the kind of summary, but of course we know we like to know more about how what we talk about, and especially what is the use of it. What are the benefits for the user? In the greenhouse, vertical farming, different options available, of course. If we look at the current way of working, current operation practice is taking samples in a greenhouse, sending it to a lab, waiting for 3, 4, 5 days. But if you're in countries where there is lab density, it's a lot lower, or you have to have a lot of logistics to get your sample at the lab. It might take up to a week or longer to get back your data of your nutrition mix in your greenhouse. And that means actually when you start to steer on that data, you're steering on week-old data, and you create a lot of overshoots or undershoots in your dosing of your measurement of nutrition. It also means you have a big gap between the measurements where everything can happen. You can make mistakes, and that can be disastrous. So if we look at what is delivering better nutrition measurement, it means that you are spot on, as you said, Cherry. There is a line, what you know, what the plant needs, and you can spot on deliver the nutrition that is needed. And that can, of course, deliver a better crop and a higher yield. You also reduce the water and the amount of nutrition you have by that. So you simply save money by being more accurate. One of the biggest reasons one of our launching customers did buy the CELINE unit was simply risk reduction, because the time gaps that nothing is measured, everything can happen. It's Murphy's Law if it's a human mistake. It can be a dosing system that has a mechanical mistake. It can be the irrigation system making a mistake from one table to another table. What is the irrigation mix? What needs to be delivered where? You only will find out already when you see the crop dying, and only afterwards you get the results from the lab. So that's a waste of time and a waste of a lot of money. On a lower scale, you can, of course, eliminate some of the lab costs and the sample taking work. This is not only on cost level interesting, but also sometimes the competencies are simply not available. In development countries where new greenhouses are built, it's difficult to get the right skills and knowledge in place. Also, for that reason, it's remote steerable. Yeah, so you have all the data in the cloud. You have the data available to go to autonomous growing and steering your dosing systems by distance. And last but not least, it's the option to go to a zero waste, zero discharge model where you can use the drain water because you know what's the content of it. You know how to add the nutrients to get to your full mix. And that saves, again, money, but also wastewater. Something about the technology. Capillary electrophoresis is the technologies that's applied here. That's where the name CELINE is coming from, the C and the E. And the capillary is actually a small glass tube in which sample of the water is induced together with liquids that will make a buffer. And there is a 20,000 volts current on this capillary. This makes the ions move either to the plus or the minus, depending the charge. And simply enough, the electromobility of these nutrients is known. Yeah, so we know which one will pass at what time, what's the order of passing. And then we have a detection unit and we can measure what's the quantity of the known nutrients that are passing by. So this is the technology and where the name is coming from, funny enough. The question is, of course, what can we measure? A lot. You see the selection of the macro, but also micronutrients. The very interesting thing about this technology is that you measure them all at once. So in every measurement, you have all of these available immediately. And yeah, you don't measure them one by one, but in the complex, you can get it clear. We detect a signal. We know what was the order of the different ions. We can calculate that to the nutrient concentrations, and we can show that in nice graphs. And this, of course, has a nice alarm function also. If there is a hurdle rate on a certain nutrient, yeah, you can immediately get an alarm bell on if it's too high or too low. And then you can steer. So even if there is a problem, you can act immediately, because the time for making this kind of calculation and measurement is up to an hour. So in an hourly interval, you have all this data available. Where are we running the business already? In the Netherlands, after a long time of testing, but also at a big greenhouse for breeding cabbage, for instance, where they have a lot of different species, and they really wanted to rule out the mistakes. So there they made that investment. And there is installations on its way for Norway. That's a hydroponic greenhouse in connection with a salmon factory. Vertical farming, UK, US. So we are running around, and we get a lot of requests to deliver. And what you can see on the right picture is the CELINE unit in the water management area. It has its own cooling equipment, so it's always on a nice constant temperature for doing its measurements. This is a joking picture, actually. We only say, hey, what is in this box? And we always respond by, it's actually the guy on the left you see working with all the stuff at the lab. We just did grab it all together, and it's automated all within this blue box. And as you can see, there is some electronics and high voltage units, some fluidics, pumps, and etc. To organize the capillary, of course. And you see also the liquids that are there for the buffering, but also for calibration and cleaning. So every measurement is brand new at lab quality, 95% accuracy. So how to implement this? These are the last few slides. This is a normal situation by today. Yeah, nutrients, irrigation tank, and rainwater, not optimal because you don't know what you're doing, and you actually waste nutrients. And of course, the time delays we did talk about earlier. Then, of course, you have the situation where you even discharge the drain water to the sewer. But it can be also more advanced on the other hand by having, besides an A and B mixing, already some separate nutrients, or even using liquid nutrients. That's, of course, very interesting to use together with this measurement tool. So how to implement CELINE? It's the hardware, it's the liquids, and it's the software. The connection to climate computers is there. And we have multiple lines that we can sample take in on request. So it's taking a sample after the irrigation tank, the water that goes into the greenhouse. We measure what's coming back before the drain water tank. But you also can measure separately, for instance, already the nutrients that are in a premix, or as in the hydroponics, the water that's coming from the salmon factory, to measure that. So there's different locations where you can measure all the nutrients and see where you combine it and you get to the right mix. And this is a picture that shows a little bit how in an advanced system with software, growing software, individual nutrient dosing systems, we can work. Of course, it takes some time to figure out with the customer how to implement it, but it's not that that difficult. So this is what we are doing at the moment. Thank you for your attention, and I can gladly take some questions.
Excellent. Okay, for those who are new in this hydroponics and recirculation, most of the growers I know sending samples and then get the analysis done and receive. We always wanted to have analytical capacity like this, but not all of them can measure all the nutrients. But Simon, if I understand correct, yours basically measure everything. Essential.
Correct.
Ions.
Exactly.
Yeah.
Exactly.
So I thought this is a game changer, to be honest. So I like to ask questions, Simon. We pay like $40 per sample. I don't know how much growers are paying, but $45 per sample. I don't know what is the range you see, but I like to know what is the return of investment in your case? I don't know if you can calculate that, but yeah, if you have some
we can. yes, we can. If you look simply at the reduction of cost for a lab and the manual work in taking the samples and the logistics to send it, and then of course it makes a difference in where you are located. And if you're in Mexico and you send your samples to the Netherlands, it's already becoming a costly business. There we are not far apart from what is conventional, but the return on investment is of course totally different if you look at avoiding one mistake. Yeah, the example I did give of this people with this cabbage greenhouse. If they make one mistake and they lose one bet, that's a $50,000 error. Yeah, so your whole investment and all the measurements for the rest of the year are covered by simply avoiding one mistake. And then we do not even calculate on the reduction on nutrients that are costly, on water, so the return on investment is actually, by all these different USPs, relatively short.
Yeah. And then also, like a US situation, unlike Netherlands, greenhouses all different locations away from. There's no hub, like Westland. So it's away from infrastructure service providers. So that's one thing. And then another thing is we have many leafy green growers who have to deal with multiple recipes. So unlike Netherlands, more like a monocrop situation. Relatively, I think we have a more greenhouses or the indoor vertical farms dealing with diverse crop species, therefore diverse nutrient formula.
Yeah, this is where especially quick measurements, quick adjustments, good checks on every change you make are so relevant. This is why this launching customer in the Netherlands has 160 different tables with, I think, about 20 different nutrient mixes. So then the chances you get into a mistake are much higher. But you also simply want to know very specific if the mix is what you want. And also if the drain water that's coming back is a mix of different tables or different locations in your greenhouse, and you have to use it again. You want to know what you are reusing and what you have to add to adjust again to the optimal. So, and the locations in the US, of course, they're widespread, greenhouses far apart, one agronomist that has to serve them all, flying around. And now behind this computer, you can simply follow the data and press the button to have the automatic dosing app, all the nutrients as he wants it, or she, of course.
Okay, couple of questions in the chat line. What are the error tolerance on your nutrient tests?
95% compared to the lab. Repeatability also 95%. And that's extremely good because if you send it to 2 labs, you will even not get to that level. So we are in between the values that you will get otherwise by having to send it to 2 different labs.
Okay. And then the following question is, how often would a system need maintenance?
No maintenance. It's cleaning itself, it's calibrating itself. Only once in 6 months we replace one part, and we are already changing that so the user can do that himself. So there is actually no maintenance. What we do is, in distance from the Netherlands, follow all the data. We can see if the machine is working fine. And if not, we can even give you a call and say, hey, you need to replace now something because we see there is a mistake. And if there is a clogging up because a filter needs to be replaced, then we see it. We know it immediately. So there will not be any collateral damage then.
Great. Does it have a compatibility with greenhouse or the vertical farm climate controller?
What we see in vertical farming is that most of the greenhouses build their own ICT environment. We simply connect there with an API, but we also have it with Priva, Hogendoorn, Ridder kind of tools. Yes.
Excellent. Great. Any other questions, even with microphone? Anyone? So the user side, do they need to know at least some basic chemistry to handle this, or no need any?
No.
Okay. So the high school chemistry works okay?
Of course, the agronomist will adopt according to the mix and the recipe.
Of course.
The nice thing is if the recipe is known, you can use it as a steering tool, and you even can get on your phone the alarms if it's off.
Great, excellent. Thank you. All
Thank
right.
you, Terry.
Next is Jaap.
Okay, well then I'll start my story. Very nice to see you all here. My name is Jaap Weerheim. I'm from the company Certhon. And what we do is we build turnkey greenhouses all over the world, also in the United States. And we have recently launched an innovation into the market, which we call Gronals. And that's where my pitch will be about. And Gronals is actually, we call it a revolutionary cherry tomato production system. So for anyone that is familiar with the cherry tomato industry, is that it should be said that the cherry tomatoes are typically grown in a high wire system. And with the Gronal system, we changed that growing method completely. So first of all, why do we want to change the way cherry tomatoes are being grown? Well, that is for various reasons. I think the current way of how cherry tomatoes are being grown is excellent for the production that it gives in the high wire system. Productions are typically high, but there are a few clear disadvantages. It is very labor intensive to grow tomatoes in a high wire system. It asks for a lot of manual handling. It is prone to pests and diseases, as you need to keep your crop at least 10 months up to a year alive and healthy. And I think the last years have been a big headache for tomato growers with the famous tomato brown virus that has caused a lot of damage. And secondly, we also need to look into energy consumption as like everywhere in the world. Also, the greenhouse industry has to work on further reducing energy consumption. So although the current way of how cherry tomatoes are being grown is good for the yield it gives, there are definitely can be improved, and that's where Gronals comes in. So what do we do with Gronals? Gronals is a new cultivation system where we smartly combine new novel genetics and automation. We have been now in a joint venture for 6 years with breeding company HW Seeds, and together with them we worked on a so-called dwarf tomato type. So whereas when you grow a cherry tomato in a high wire system, this crop grows indeterminately long, so it keeps on elongating for its entire lifespan. Our Gronals tomato plant essentially stops growing when it reaches a height of around 40 centimeters. And then once it stops growing in height, it only has one single flowering period. In that flowering period, which is short, around 10 days, all the flowers in the plant flower and are being get pollinated. And then after the 10 days of flowering, it's only waiting for the flowers to grow into fruits and to ripe the fruits off until you have all the fruit ready on the plant. And then also very different from a high wire system, all the fruits on the plant are harvested in one go, and as of that moment, it's also the end of the plant's life. So we grow in, as I said, in determinate plant type, and we grow from seed to harvest in around 15 weeks. As said, all the fruits are ready at the same time, and with a system like this, we have proven that we can grow to annual yields of around 50 to 55 kilograms a square meter, which is for cherry tomatoes really high. Gronals, we've been working on Gronals for the last 5-6 years in our own innovation center, which is the Certhon Innovation Center, which is located in our headquarters in the Netherlands, where we have done trials and trials. I stopped counting, but I guess it's around 50 trials where we've been optimizing the growing recipe and also the genetics in order to come to a workable system. If we look into more detail how growing tomatoes with a Gronal system is different from a high wire system, well, first of all, we should look into how for what time period the plants stay in the greenhouse. With high wire system, it is around 10 months or up to a year. And in the grownal system, one cultivation cycle only takes 15 weeks to go from a seedling to one final harvest. In a high wire system, we have clear peak and down times in the production, specifically around the cultivation cycle change. There is no production at all, no tomatoes coming out of the greenhouse, and in midsummer it will be very high production. Whereas in the grownal system, you can plan your production a lot more better because of the short cycles, and you don't have that one single big cultivation cycle change. So it is a lot better possible to grow year round with consistent production and consistent quality. And of course, the high wire system is labor intensive. You have various activities: pinching, turning, dropping, removing of leaves, obviously the harvest. And in the grownal system, all the activities related to the high wire, they are not needed anymore. So the amount of labor that stays left is very minimal, which is, I think, for every grower, an excellent feature of the grownal system. How the cultivation cycle exactly looked like, I said it takes 15 weeks to grow from seed to harvest. So we start with around 18 days for sowing and propagation at a very high planting density, around 500 plants per square meter. Then after the 18 days, plants are transplanted to the next phase, which we essentially call the first cultivation phase. It takes around 2 weeks. We lower the planting density to 24 plants per square meter. And then after that period, we go to the final stage. That is by far the longest phase. It takes around 73 days. We grow at the final planting density of around 16 plants per square meter. And this is also the period in which the plant flowers and the fruits develop and mature until they are ripe and ready for harvest. With the 15 weeks, in order to grow year round, it should be said that sowing, propagation, and cultivation are parallel processes, and they all take place year round. I think the best comparison can be made with lettuce, how it's currently grown on MGS systems, where growers always propagating and harvesting at the same time. And this is the same approach that should be applied to growing tomato plants with the grownal system. A little bit about the automation, on what system we use to grow the plants. The plants are typically grown on a mobile table system or a mobile bench system. This is not really a newer novel system. It's already known for decades in Holland, mostly from the ornamental industry, but also from the cannabis industry, and also lettuce can also be grown on these systems. But we have now made it suitable also to grow tomato plants on this system. Well, if you apply a mobile bench system in your greenhouse, there are obvious advantages of doing that. First of all, you don't need any people in your growing facility anymore, meaning that you can efficiently use the space. You reduce the manual labor, and infection risk by people entering your greenhouse is, of course, also minimized. Something about the harvest. If you have a plant that only has a single harvest, that means that when you are harvesting, you can destroy the plant during the harvest. You don't need to keep the plants healthy and firm as you would need in a high wire system. So that means that we can relatively easy automate the harvesting. So we have designed a harvesting principle in which the plant gets destroyed during the harvest. We do that by with a machine like this, where the plants are being separated from the substrate with a belt saw system, and after that are transported by a conveyor belt system to the actual harvesting device, where we essentially shake the plant, and by simply shaking we can separate the green plant and the red fruits into two separate streams. So we end up after the harvesting with one green waste stream and one nice red fresh tomato stream. And by automating the harvesting process, we can again eliminate a lot of manual labor. To summarize, what we see as the key advantages of the Gronos system compared to a high wire system. There are four key advantages that we see. First of all, we have proven that we can grow very high yields with this system, 50 to 55 kilogram per square meter annually. In a regular cherry tomato production system based on a high wire, this is not seen. We can strongly reduce labor when growing tomatoes with Gronos, and we have made detailed calculations together with Dutch growers, and we estimate a saving of around 80% of all the manual labor that is needed per hectare to grow cherry tomatoes in a high wire system versus growing cherry tomatoes in the Gronos system. Third benefit of growing with Gronos is the way plant health management takes place. And this has several aspects. First of all, the cultivation cycles are only 15 weeks compared to 10 months or a year in a high wire system, meaning that the lifespan in which a plant can get infected is simply a lot shorter. So that means that, yeah, it's easier to, and you have a bigger chance to keep your plant healthy. Secondly, there is no crop handling required. So all the activities related to the high wire are not there anymore with the short Gronos crop. And therefore there are no hands needed no manual hands needed to basically touch the crop. So in a high wire system, you can easily have four crop visits a week per plant, either for harvesting or for deleafing or for turning. That means that you have 4 times a week a chance that people are spreading plagues through the greenhouse, and with the Gronos system you don't have that chance anymore because you don't need all these handlings. And thirdly, if for some reason a plant gets infected, the economic loss for that plant is relatively low because you're going to replace it anyway after 15 weeks. And last, growing with Gronos makes you a lot more flexible, and your plantability increases. If you have only cycles of 15 weeks, you can respond to trends in the market and in the season by offering and growing different colors, different varieties over the year. Whereas with a high wire system, you only have that opportunity once, or you can only choose what kind of tomato you're exactly going to grow once a year. And with the short cycles, the production becomes plannable and also more flexible. And I think that is basically what we wanted to say about Gronos. Maybe to end up, we have trialed this system for years in our own R&D facilities, and we're now trialing it at several customers. And of course, this is a big step for the industry to move away from the high wire system and to adopt a different growing method. But we believe this is really the future of growing tomatoes by saving labor and making plant health management a lot more better.
Excellent. Thank you so much. Yep, I'm so excited. Okay, so would you like to make a comment about adaptability of Gronos in this kind of system, multi-layer production system?
Yeah, sure. Maybe it's good that you asked. I didn't mention it explicitly, but this system is of course very well suitable for growing multi-layer. If you grow a high wire system, you need 5-6 meters in height, making growing vertically very challenging. If you have a plant of only 40 centimeters, that becomes very well possible. So yeah, the Gronos system is perfectly suitable for going indoors and expanding the vertical farming industry beyond leafy greens now also with tomatoes. Nevertheless, the system, all the benefits of the system, they also stay apart when you apply this in a greenhouse. Both methods are possible. We have trialed both.
Excellent. Anyone questions while you are thinking? So grafting, necessary or not necessary for this?
No, grafting is not needed. No, grafting is not needed, fortunately, as your crop only stays fit for the 15 weeks. And
Okay.
grafting is not needed. And
Well, it
also,
just doesn't make sense
no, it doesn't make
because
sense.
it's short
it,
crop. Yeah.
Of course, and it would also mean that we're introducing manual labor into the
Oh,
production.
Yeah, true.
Which would be opposing against what we aim for with Kronos.
That's
so
right.
in our breeding pipeline, we have also accounted for that by ensuring grafting is not needed.
Okay, good. Does the system require cultivar specific crops, dwarf varieties? Correct.
Yes, sure. Well,
yeah.
As Certhon, we are co-owner of these dwarf genetics. Dwarf genetics are not new; they have always existed, mostly for the open field where they are growing, let's say, low-tech tomatoes or even peppers. But these varieties from the open field are far from suitable for growing in GEA space. So that's where our work started with these low-tech genetics and upgrading them to genetics that are suitable for growing in a greenhouse or a vertical farm. These genetics we've worked on these with HW seeds. To the best of my knowledge, there are hardly any other suitable genetics yet than that we have developed.
Yeah, so
probably they might come if we do a good job, and if we sell this system properly, also the big breeding companies might step into this as well. Why not?
So my understanding is in addition to being dwarf, compact architecture, sort of synchronizing flowering for the one-time harvest at the end is another important characteristics, correct?
Exactly. Yeah. You need to have that one short extensive flowering period in order to make it possible to harvest everything in one go. And also the taste from the existing dwarf genetics from the open field is usually quite poor, not good enough for a CEA product. So taste is definitely important in the breeding pipeline, of course.
Yeah. So how do you manage the pollination? Is that like a very short window of pollination? Is that going to be bee-based pollination anyway?
Yeah, so the flowering is extensive in a short period.
Yeah.
So that's the period, of course, in which pollination needs to take place. It can be done with bees, technically, but we're not fan of that. We have developed a mechanical pollination method. That is because if you're doing this on large scale, you will have plants of all different phases in your greenhouse or in your vertical farm. And you don't want your bees to move to plants that are already finished in pollination, or we don't want to pollinate them yet. You only want them you want to target them. Well, with bees that's challenging. That's why we decided we're gonna do it with a mechanical pollination device, which is part of the concept, part of the cultivation system.
Excellent. Okay, so maybe that's related, but when you apply this in the indoor vertical farm situation, Stephen asked if there is an issue of ethylene gas building up.
That's an interesting. That's an interesting question. We have indeed faced that, but that was in a very small, concentrated growing area. Like said, well, the growing and the cultivation cycle takes around 15 weeks. That means that if you grow this in a vertical farm or in a greenhouse, you will have plants from the day one since sowing, or plants at day 105 ready to harvest in the same growing room. Meaning that some of your plants will definitely produce ethylene, but not all your plants at the same time. So ethylene is usually not a problem when you do this on big scale. And a more practical thing is there in greenhouses. Greenhouses are leaking or exchanging air more than enough, and most vertical farms, I guess, as well.
All right.
That's a good question.
Good. Well, excellent. It's actually on time. Excellent. Well, so the three speakers, Simon and Michael and then Jaap, thank you so much sharing the newest technologies pretty much with us. And then I'm looking forward to seeing that in US, North America, more used in here. So thank you so much. Excellent. Appreciate. Everyone,
Thank you, everyone.
for-
Thanks for having us.
Thank you, everyone. Thank you. Bye.